So when multiplying minuses, that become positive,
Yeah.
right?
Yeah.
Okay. So I think P is -3 and Q is -4, I think.
That's 4. Nope.
Nope.
So what was your working out?
So I did 2B,
So what is...
then I got
Yep.
6.
Should be -6.
Oh, that's why then. So -6 and -8.
Yeah.
And then you take away C from that, so Q11. And then you do -8 -11. You get -19 over -6 minus Q equals 2 over P. Well, 2P, sorry.
So -19 is P.
Yeah.
And then this one... What was Q?
Q was -6 minus Q equals 2. Which gives you -6. Wouldn't it be plus, not minus?
Just solve the equation. -6 minus Q equals 2.
Add add 6 to both sides,
Okay.
which gives you 8 minus Q equals 8. And then do you want to make it negative?
Mm-hmm.
So it'd be -8, so Q is -8.
Yep. There you go. -19, -8. And if in doubt, even for a simple one, you can always solve it using the calculator. Yep. Looks different. Should be the same thing.
Okay. So wouldn't B minus A be -10I plus 10J, but wouldn't it be -10QI plus 10PJ?
No. B minus A. What is B?
B is -4QI plus PJ.
I plus PJ. Minus A. So that's going to be take away
Yeah.
And that gives you that.
Yeah.
How would you go about it?
Could you expand the bracket first?
Yeah, what would you get?
Okay. So would you expand it by -1?
Yeah, very good.
Okay. Which would give you -2pi and then -3qj.
That's it.
And then would you simplify?
I don't believe you can. Is there any equation you can make? Or just consider the I direction.
What do you mean when you say I direction?
So I is like in the X direction, it's 1 to the right basically, and then J is 1 up. So if you look at just the I's,
Yeah.
-4qi -2pi equals -10i.
Okay.
And then
right.
you do the same for the J direction, and you can divide everything by I if you want to make it simpler.
Okay. So if you divide by I, it just gets rid of all the i's.
Yep.
So it gives you -4q -2p equals -10.
Yep.
Okay. And then do we solve?
One equation with 2 unknowns can solve it.
Okay.
You need 2 equations with 2 unknowns.
So could you do J now?
Yep.
Okay. It should be pj -3qj equals 10j. Then you divide by j.
Yep.
For everything. Which gives you p -3q equals 10.
Yep.
Could you solve it as a simultaneous equation?
Yep.
Okay.
This thing just blocks the whole screen. -4 -2.
So you know do they have to be in line, like the q and the -4q? Do they have to be like below and above each other?
Yeah. So it could be like the X's and the Y's.
Okay.
Oh, that's a good point. They swapped around in our one, so we have to swap them around. So yeah. So that's not right.
I got x is -1 and y is 7.
And so which is which?
Is p -1 and q 7? I think.
Yes, I believe so. Let's see. So x is -1. That was the first one, and that was the So I believe Q is -1. Is that what you said?
No, I said P.
That's my guess.
Okay.
Yes.
Yeah, that's right.
So just keep track of them, because it was in the second one that I swapped them. Okay, great. So it's very similar to this one, except it was simultaneous equations. This one's written in column notation. This is written in the INGA notation.
Yeah.
So make an equation. You need another. Make a second equation. Solve it. Any questions there?
No.
This is good. This is very similar. Let me see. Very, very. All right. We'll do this just so you. Go on. You should be able to do this.
So there's J4 and K11, I think.
Yep. Great. So you're good for those.
Yeah.
Let me see something here. Yeah. Let's see. Is this worth doing?
I don't know.
Go on, give it a go.
Okay. How would you solve this one? Because all of them unknown, like P and Q for all of them.
Make an equation. So, what equation can you make?
Could you make a simultaneous equation?
Yep.
Okay. So it would be P plus 2Q equals 7. And then 2P plus minus Q, or minus Q, equals 4.
Yep. That should work out. And you swap them around.
I got X is 3 and Y is 2.
3 and 2. Yep. Good. Yeah. Good. So that'll be alright. Let me see. So this is the more challenging notation.
Okay.
I think this is going to be okay. Let me just take a look. Okay. Yeah, try this one. It's not obvious how you go about this, I believe.
Okay. So when doing these questions, you need to put it into like an equation together, because you don't know if you need to add or minus to get what P and Q is.
So there's a kind of a trick to this one. The resultant of the vectors is parallel to that. So that's like A plus B.
Yeah.
So you might think A plus B is equal to C, but it's actually parallel to C. So it's C times something, and we usually write it as K.
Okay.
So A plus B is equal to K times C. So it might be double, it might be triple, it might be half, it might be minus a third. So A is 3I minus 2J. B is Pi minus 2Pj. And that's equal to K times 2I minus 3J. And so pick either... well, what would you do next?
Could you get rid of P, but then P is someone you want to solve, but...
Make an equation. So much
Could you make
a
simultaneous equation?
Yeah.
So it'd be 3I minus 2J.
Mm-hmm. Let's say I is only.
Okay. 3I plus Pi.
Okay. Gives you?
Equals K. And then would that equals K 2I minus 3J?
Just the so if you were to expand these brackets, what would you get?
K 2I and minus K 3J.
Yeah, I'll write it as, you usually put the number first. So 2Ki minus 3Kj.
Yeah.
So basically 3I plus whatever P is, Pi has to give you 2Ki.
Yeah.
Whatever that's going to be. Okay, J direction.
Okay.
Or whatever you think next.
Minus 2J minus 2BJ equals minus 3KJ.
Mm-hmm.
And then can you put that into the calculator? Or because we don't know what K is, can you still put it into the calculator?
You can. You can just ignore the I's and ignore the J's, or you can divide everything by I, divide everything by J.
Okay. So if you divide everything by I for I,
Mm-hmm.
you get 3 plus P equals 2K. And then divide everything by J for J. Minus 2 minus 2P equals minus 3K.
Yeah. And so there you've got two equations, two unknowns.
Yeah.
And you might need to move stuff around or whatever for the calculator.
You want to flip the K and the P around?
You want the two unknowns on one side of the equal sign. That's just how the calculator takes it in.
Okay. So do you want to flip the minus 2 for J? Wait.
For J, yeah, you want the minus 2 on one side of the equal sign by itself, however you do that.
Okay, so it'd be 3K minus 2P equals 2.
Yeah, looks good.
The other one would be minus 2K plus P equals minus 3.
Mm-hmm.
And then can you put that into the calculator?
Yep, that's good.
So would it just be written out as minus 2?
What would be... What?
For I, would it just be minus 2, not minus 2K? When putting it into the calculator.
Yeah, it's like minus 2x.
Okay. I got X is 4, Y is 5.
Okay, let's see. So which is x, which is y? Oh, hang on. I'm getting minus 8.
Wait, let me check. Minus 2k plus 1. I put in minus 2 and then 1 and then minus 3 and then
That doesn't look like
3.
minus 3 to me. Wait. Yeah, it does. My mistake. Wait. No. Maybe. Yep, minus 3. I forgot the minus.
Okay.
Minus 3. Yep. 4 and 5.
Yeah.
Let's see if that's our happy day. Let's delete these. 4 and 5.
Yeah.
Okay, so part B then.
Okay.
The resultant vectors of A and B.
So we just need to sub in what they are.
Yep.
Okay. So would you sub it in A? Would you sub A for A? Would you sub it into 3i minus 2j?
That one we don't need to sub anything into. Nothing we can sub into.
Then.
Yeah, into B.
Okay. So is P what 5?
P is. What order did we put these in? Yeah, P is 5.
Okay. So it'd be 5i.
Mm-hmm.
Minus 2 5j.
Yep.
Which gives you 5i minus 10j.
Yep.
Equals B.
Yep. Any idea how you find the resultant of A and B?
You have to add.
Yep.
Them together.
Yeah.
Okay. Which gives you 8i minus 12j.
That's it. So that's the answer. And I just want to see something. So we said that that was equal to K times the other one. K was 4 and the other one was 4, 2i minus 3j. So 4 times 2 is 8. 4 times minus 3 is 12. Minus 12. Yeah, so it works out.
Yeah.
Great. 8i minus 12j. And so that's, yeah, we needed, well, big picture for this one is resultant of A and B is parallel to vector C. That means the resultant of A and B means A plus B. If it's parallel to C, then it's equal to K times C, where K is just a scalar. It's just a number times by it. And so this A plus B is 4 times bigger than C. Yeah. C is 2 right, 3 down. These two added together are 8 right and 12 down. Yep. All right. Any question with that?
Nope.
So, oh yeah, we're finished that one. Okay, good. All right. So, what do you give yourself for that previous malarkey?
Probably between tick and a half.
So, I'd like if there was one more parallel question. Let me just make a note to myself if I can find it.
Yeah.
Because that K times thing, K times C type stuff. Okay. Yeah. We'll get to this in a second. Okay. Any idea what this is about? Part A.
What does it mean if there's lines between A?
So that means the magnitude of A. What's that about? That means that A is 3 right, 3 right, 4 up.
Yeah.
So that's 4j, that's 3i. And on a vector diagram, magnitude is represented by length. And so you would find the length of the line, the vector 3i plus 4j.
Yeah.
And so how would you find the length of that line?
Would you need to use simultaneous equations?
You would need to use Pythagoras. And you can do it without the I and j.
So A squared plus B squared equals C squared.
Mm-hmm.
So 16 plus 9 equals C squared. 16, 25. And then square root of 25 is 5. So the answer is 5, I think.
Yeah, so the magnitude of A is 5, and that's that one. Let's try question C.
Okay. So do we need to do Pythagoras for both? Right.
So you would find so it's like brackets. So you'd first find 2a plus b, and then do Pythagoras of that.
Okay. So 6i plus 8j plus minus 2i. So I got 4i plus 4j.
Okay.
And then you do the Pythagoras.
Yep.
I got 4 square root 2.
4 root 2 sounds all good to me. 4 root 2. This one up here was 5. We're going to be good. So you just work it out and do Pythagoras.
Yeah.
Right, unit vector. What's this malarkey? Let's see. A unit vector is any vector with a magnitude of 1. You need to be able to find a unit vector in a given direction. Unit vector in direction of A is A over magnitude of A. If A is 5, then it's like a fifth of that. It's a fifth of A. So you have to make the magnitude 1.
Yeah.
A over magnitude A. Alright. Let's see if we can figure this thing out. So part B. Find a unit vector in the direction of A.
So it wants a number that the direction of A is going in.
It's basically A over magnitude of A. So what is A?
3i plus 4j.
And what is the magnitude of A?
5.
And so instead of saying that over 5, I think it'll be easier to write it as a fifth times that. So a fifth of that. So its magnitude is 5. So you have to times it by a fifth to make its magnitude 1. So it's a unit vector. One single unit. There we go. 1/5 3i plus 4j. Or you could write it as 3 over 5i plus 4 over 5j. Or you could write it as 0.68. Many different ways.
Okay.
Yeah. All right. Okay. So let's try this one before we do that. Why must they never make my life easy? What's this one? Right. Let's give this a go.
Okay. So would you write it out and divide it by p, or would that not work?
What do you mean write it out?
Like 2pi plus 3pj equals 7 root 13, and then could you divide by p?
What are these lines about?
You need to work out using Pythagoras.
Yep.
Okay. So it'd just be 9 plus 4 equals 13. Square root of 13 equals...
Hold on. That'd be nice, but you also have a p, and p is a number. So the first
So
bit...
it'll be 2p squared.
4p squared.
4p squared. Add 9p squared. The square root of all of that, which gives you 4p plus 9p, which is 13p.
I don't know what to do with you. You just said p squared for 1.
Oh, I forgot the I, the j.
Yeah, for 2 it's I and j, so different directions. So it's like x and y. You can't add them together.
Yeah.
Maybe you're onto something. Yeah, you are onto something. Get rid of I and j. Okay. So it's not 13p. What is it?
It's not 13p.
What should it be? Something's missing.
Square root of 13p.
Something's missing.
Squared.
Yep. So square root of 13p squared is 7 root 13.
Yeah.
Okay. Solve.
What do you mean by solve?
Solve for p.
Okay. So would you divide by 13 on both sides?
You can't because it's inside a square root.
So you square both sides,
Well done.
which gives you 13p squared still.
Yep.
And then what would happen to the right side?
Calculator.
Okay. I got 91.
Yeah. 7 squared times 13. Are you sure you got 91?
I put root 7 root 13, then above the root 13 I put squared.
You must literally 7 root 13. The whole thing. Just put it in one big bracket.
Okay. $637.
There you go. It's so the bit on the left was that squared. The bit on the right is like 7 squared times root 13 squared.
Yeah.
So it's like 49 times 13. Let me check. 49 times 13. Yeah.
Yeah.
Okay. Solve.
Could you square root both sides?
Not yet.
Would you divide by 13 on both sides?
Yeah.
Which gives you p squared equals 49. Then you square root both sides, which gives you p equals 7.
Hold on. 91 divided by 13. What is 91 divided by 13?
No, I thought it was 637.
It was 637. It gives you 49, does it?
Yeah.
Yeah, that makes sense. Okay, so what is P?
7.
Why does it say values of P? What other number gives you 49 when you square it?
Minus.
Yep.
49. Plus or minus 7.
Yeah. Here we go. Plus or minus 7. Yeah, so basically the magnitude of this thing, so this is in reverse. So before it was, here's a vector, find its magnitude. You do Pythagoras. This time you're told, here's a vector, its magnitude is this, find out what originally was.
Yeah.
Make an equation, solve the equation, 2 possible solutions. Any questions there?
Nope.
Just put the whole thing in the calculator. Just big brackets like that. Take the nuclear option. Let me see this one. Okay. Alright. Similar.
Okay.
One sec. What question was that? 6.
So could you write out as square root 4 plus k squared equals to square root 10?
Yeah.
It's k6.
Are there 2 possible values?
Plus or minus 6.
Don't know. It says value. I was just expecting there to be 2. Yeah, plus or minus 6. Yeah. Okay. Don't forget the minus. You've got the idea.
Yeah.
Alright. Back to Crazy Town. Okay. We were doing this unit vector malarkey. We now have to do angles. Okay, how do we do this?
So I is going to the right, so 4 to the right and 5 up.
Mm-hmm.
And it wants the angle in between. So
Yep.
bottom right angle, right?
Yep.
Okay. But how come when it says find the angle between the vector 4i plus 5j, it's in the bottom left, not the bottom right?
And the positive x-axis.
Oh, okay.
Yeah, so
Right.
like negative x-axis would be there. You know, they do have to specify.
Yeah.
They might say the acute angle. They might say, if they said between the y-axis, it'd be the top angle. Yeah.
Okay. So would you work out you use Pythagoras to work out the hypotenuse?
Nope. Don't need to.
Would you use trigonometry?
Yep.
Okay. Would you use the cos rule?
You are too smart. Well, what you could do is find the hypotenuse using Pythagoras and then use the cos rule. Or, because it's a right angled triangle and the cos of 90 is 0, you could do SOHCAHTOA.
Okay. Would you use TOA?
Yep.
Because you've got opposite and adjacent, right?
Yep.
So it'd be to be O over A, right?
Yep.
So it'd be opposite over, which is 5 over 4.
Yep.
And then 5, which is 1.25.
Change to degrees. I think you're in radians, are you?
Change to degrees.
No, sorry. You're in something else. That's fine. So that's 1.25, is that what you said?
Yeah.
Okay. That's tan theta. We want theta.
We just do inverse tan.
Yep.
Okay. Inverse tan. It gives you 51.340.
Say 51.3 degrees. 3 sig fig. 51.3. And yes. Let me see. So this is I, this is J. It helps to have a diagram, but I suspect that if it's between the vector and the positive x-axis, then it will always be arctan of the J over the I.
Yeah.
Something like that. It'll always be that. That's between the positive x-axis.
Yeah.
Let me see. There's not going to be any. Oh, that's a doozy. Let me see this one. A, O, B. One sec. Yep. Q to P. Let's take a look at this one. All right. No, they're just mixing the action straight away. Okay, how about this one?
Okay. So what does it mean by with j at the end?
J, positive y-axis.
Okay. So would you use cosine rule for this?
It's a right angled triangle, so I don't think you'll have to. Let me see. So this there.
We got 10. A is 10, right?
So that's 10. Makes an angle of 30. Okay. Anything you can do there?
Well, we know that the angle's 90. Would you use K?
Let's see. Okay, yeah. What would you get?
You just get 30 multiplied by 10.
Yep.
So it'd be 10 cos 30.
Mm-hmm.
Right?
Yep.
Which gives you 5 root 3.
And so what is this 5 root 3 in the diagram?
That is the adjacent.
So which side is, where is that?
Left.
Yep. So that one is 5 root 3.
And is that I? Is it?
That's in the y direction, so that'll be j.
J. Okay. And then could you use Pythagoras to work out what the last angle, the last length is?
You could. Let's use sine.
Okay. So be opposite over hypotenuse.
Mm-hmm.
Do we have the opposite? So it would be equals. So would it be 30 equals O over 10?
Yeah, sine 30.
Yeah. And then would you divide by 10 on both sides?
It's already divided by 10.
3.
What's the opposite of divide by 10?
Oh, times by 10.
Yep.
What, so would it be 10 sine?
Yep. So going up was 10 cos 30. Going across was 10
Oh,
sine.
that's 10 sine 30.
Yeah.
Which is 5. So I is 5.
So the I direction is 5. Okay, so what is the vector A?
Vector A is 5 on the top, and then 5 square root 3 in square root 3 in the bottom.
You're right. 5 root 3. They wanted it in column notation. I was going to write it as 5i plus 5 root 3
okay.
j. No, you're correct. They said column vector notation. 5.
Okay.
5 root 3. Yeah, so it's basically 10 sine 30, 10 cos 30. There we go. Yep, great. Okay. So we didn't use the Pythagoras in any way. We could have.
Yeah.
Let me see this one. It has a magnitude of 10, angle of 30. Magnitude of that. And does it tell us the angle? No. They're never easy. Magnitude of 10 doesn't tell us the angle. Alright. See, I noticed that the exam questions are always in reverse. Anyone can do the straightforward thing. That's what it appears to be. Okay. Alright.
So in that diagram we drew, the top left 11, yeah.
Given that A makes an angle of 20 degrees with the positive y-axis, how can you use that?
So would 20 be the opposite of it?
Here?
No, that's 90.
So which angle?
Wait, and the y-axis would be the top.
Yep.
So could we use Ka?
Yep.
So to be cos 20 equals Q over 11.
Mm-hmm.
And you'd multiply by 11 on both sides. So 11 cos 20 equals Q.
Yep.
Which gives you 10.3.
Okay.
Okay. And then could you use Toa?
No. Well, yeah, I suppose. But don't.
So you'd use So.
Yeah.
So sine 20 equals P over 11. Or it could be written out as sine 11 sine 20 equals P.
Yeah, great.
Which is 3.76.
That's it. So tan would also work. It's because the question gives us 11 and 20. And so if we use those, we're definitely right. And we're definitely exact. With this 10.3, you'd have to do it to 5 sig fig and all that.
Yeah.
But big picture here is Q is 11 cos 20, P is 11 sine 20.
Yeah.
And that's what I'd be looking for. Okay, say it's 3 sig fig, and it becomes very useful with what's that called? Very useful with vectors in mechanics. Let me just see. Let's see, the positive. So yeah, another backwards thing. Yeah. All right, we'll get there. We'll get there next time. Okay, so magnitude and direction. What do you give yourself?
It will be a tick. It's pretty easy.
Pretty easy. Vectors are never easy. All right. Yeah. How was that for you, Adam?
That was great.
And so finish this next time.
Yep.
Any questions in general?
Nope.
All right. Well done, Adam. You did great.
Thank
and
you.
I look forward to attending again next time.
You too.
All right. Take care. Goodbye.
Bye.